Welcome back, I'm that chemist, and today we have a story where somebody put a piece of potassium in their pocket. I still remember the very first time my sister did a lab project. When she was in the third grade, and right before spring break, the teacher gave everyone in her class cocoons that were about to turn into butterflies. She watched her cocoon religiously. I don't think she even slept until the day came that the butterfly began to emerge. Eventually the butterfly got the strength to start flying, and mind you, it was around the time that we had gotten a new puppy, so this butterfly's time as a butterfly was cut short, as it flew directly into the mouth of our puppy. I'm sorry to hear that. What was that puppy supposed to do? I bet that butterfly was so cute, it's no wonder that the dog just ate it up. Oh boy, I remember about 15 years ago, a truck near my town got into an accident. Loaded with calcium carbide. The worst was, it was an illegal shipment, so no protection of any kind, just a flimsy tarp over the rocks. The cherry on top was that it was during the rainy season. The truck literally burned for days. They eventually caught the driver and the other people involved. I have no idea how no one got hurt, but oh boy, you could see the flames literally a kilometer away. So in another Chempilation, I briefly mentioned that there was this mishap with somebody involving iodomethane. Well, it turns out that recently there was another mishap where, in the shipping process, one of the bottles broke in the shipping facility. So you shouldn't really be shipping chemicals unless you're trained and qualified to do so. And you might think it's not that hard. It came in the appropriate packing. I can just ship it out in the same packing. You should not try and ship hazardous goods without having the proper training to do so. I'm fairly certain that there could be some legal punishments for this type of thing. If you're doing any type of home chemistry at all, make sure that you've gone through the appropriate training before shipping any chemicals whatsoever. While this might result in a fine or a lawsuit for you, it could also harm a lot of people if you don't do things safely. My advice would be to not ship chemicals as an individual at all unless you're 100% sure that you're following the proper procedures to a T. Nobody else deserves to deal with your mistake when it involves chemicals. Take responsibility and don't create problems. I used to be an industry kitchen cleaner, now working in a paint factory surrounded by other fun chemicals. I had heard stories about people spilling buckets of caustic soda, sodium hydroxide on themselves, usually whilst in the extraction duct, but occasionally when passing the bucket in or out of the duct. Also, these buckets would be of varying strength, as it was mixed from crystal form, and sometimes people would have to strip off and jump in a sink of soap to wash off or have buckets of soap chucked at them. However, we used to clean the filters from the extraction hoods in a sink of caustic next to a sink of soap to avoid damaging or discoloring the floor with caustic drips. Luckily, I've never heard of anyone jumping in the wrong sink. I don't know how safe any of this is. This all sounds quite dangerous to me. If you've ever heard of something like this before, you can let me know down below. Also, I never used to take eye protection too seriously, as I wear glasses. That changed after getting an eye full of dirty, gritty caustic while in a confined space, about 3 minutes crawling from the exit. P.S. We also used to store bags of caustic soda less than a quarter meter away from bags of sulfamic acid, both in crystalline form, and after seeing what happens when you mix them, they should have definitely been a lot further away from each other. Yes, you should not be storing acids next to bases. That is a recipe for disaster. I found an article on silver plating in a 50s electronic magazine with instructions for creating a cyanide-based plating solution. It then suggested that, for safety, any excess cyanide should be flushed down the toilet with 2 flushes. This kind of reminds me of that one episode of Hamilton's Pharmacopoeia, where Uncle Lester flushed all of his mercury waste right down the toilet, and it splashed absolutely everywhere. Man, watching that mercury just slosh everywhere all over the toilet, it was absolutely hilarious. But do not copy it, that's terrible. Old building from the geologist. My undergrad geology department was in an old building. We were on the 2nd floor, the basement, and the chemistry department was on the 3rd and 4th floors. When chemistry moved its labs to the 4th floor, they put in all new, neat-looking fume hoods. While putting these in, they took no notice of the vent stacks that pulled in air for the geology labs. Those inlets, immediately below the chemistry outlets, were totally functional, but nobody noticed until one of the geology professors, Geochem, started having a set of weird symptoms show up. What was happening was any time dense gases came out of the chemistry stacks, it got sucked in by the geology inlets. The professor recovered, but went ahead and retired, and the school had to rebuild the entire vent system. In my mind, this shouldn't have happened at all if anybody qualified with HVAC was doing this. This is akin to old civilizations who would dump their waste further up in the river and then get their drinking water further down in the river. Absolutely ridiculous. The soil eating story reminds me of the time I visited a perfume synthesis lab. The gas chromatography detector that they used was just a guy wearing a mask, coupled to a GC column, identifying the substances by smell. This is apparently a serious technique called gas chromatography, olfactometry. The lab techs endearingly call it GC sniff. I haven't heard of this before, but this sounds incredible. If you have any stories about this, I would love to hear them. I have one kind of related story. So I know somebody who worked in a pheromone lab, and instead of having your traditional mass detector for a GCMS, they would actually have like an insect antenna, which then had like a force sensor connected to it. So if it was like a pheromone that was recognized by the antenna, they would be able to get like a force trigger. and then they'd be able to tell whether it was an active pheromone or something that was closely resembled to an accurate pheromone. What they would do is they would inject an extract from that organism, maybe not from that specific organism, but from another, another ant or something. They would then volatilize all the different components, and as they would come off, they would try and identify what pheromones were active from this species of ant or whatever. And so then what they would do is, based on the retention time, because they've got a really big data set, they would be able to figure out roughly what the structure was based on when the compound came off the column. And so then what they would do is they would go and synthesize what they thought the molecule was, and then they would test those until they got a hit. And they've actually developed products that way that are now on the market. Since this works with insect antennae, I'm not super surprised that it would also work with a human nose. Although I would be a little bit skeptical to be the one connected up to the GC. Secondhand molten metal story. My father, an ex-coal miner from the Welsh Valleys, ended up working for an aluminum foundry. They mostly recycled scrap, swarf, and pellets into new alloys in ingot and pellet form using various forms of furnaces like wells and rotary furnaces, and they also added new metals or fluxes. One shift, he was working on an alloy for the motor industry that had a very low viscosity compared to other alloys when molten. They were making pellets and ingots. To make the pellets, they channel molten metal into a device that just lets small marble-sized pellets form. The workers would manually scoop out some of the stream with a ladle and pour it into molds. As they cooled, another worker would take them out and stack them and return empty molds. A stack of molds was brought in from outside, and they'd been left in the rain. No one thought to dry them. The common method was to leave them near the furnace for a time to let the heat evaporate off any moisture and then bring them over to be used. My dad poured a ladleful into a wet mold and it exploded, spat molten aluminum everywhere, and a tiny coin-sized blob managed to get past my dad's apron and hit his ankle. It slithered down the protective overalls and got into his boot. It burned and fizzled down his ankle, instantly melting his sock and cooking and boiling his flesh. Yikes, that is terrifying. By the time everyone jumped in and tore his boot off, it had given him third-degree burns. The damage wasn't a large area, but it destroyed the nerve so he didn't feel much pain, and in some places it burned to the bone. He said that the air was full of the smell of burnt plastic from the nylon sock and the stink of burned meat. The damage he got was in that coin-sized line down his ankle to his foot. Luckily, no irreparable damage was done. He even avoided needing skin grafts. It was very painful, and he was off work for several months, but he got both sick pay and some compensation for the safety violation of the wet molds. He was very lucky. For a bonus fact, not a story. The mention of chemicals in cars. There was a period when Formula One used toluidine in the fuel to get more power than just petrol or methanol. That last anecdote's rather interesting. I'm so sorry to hear that that happened to your dad, and that is the scariest thing about molten metals, is they're very dangerous and they're very hot. When you have something melt, it requires a lot of heat, so when something solidifies, it releases all that heat. So in addition to the really, really hot metal, as it's cooling, it's solidifying and also releasing more heat. And so that's why a burn from a molten metal is really dangerous. I'm glad to hear that your dad got time off work, but I wish that that situation could have been avoided. That's awful, and I hope nobody else ever has to experience that. I have successfully managed to produce sodium metal with the electrolysis of sodium hydroxide over a wood fire. I had managed to make a couple of drops. I got splashed with some molten sodium hydroxide on my hand, and now I have a scar that's 2 millimeters wide. This is kind of like the last one. You might not know this, but you can actually melt sodium hydroxide if you get it hot enough. And one of the main ways people make sodium is using this process. When my dad was in high school back in the 1970s, he and his buddies were trying to make a stink bomb in class using the chemicals that they had on hand. I don't know what those chemicals were, but immediately when they heated it, it caused their beaker to explode. My dad lost some vision. One boy had some chemical burns on his hands, and the other boy lost all vision in one eye. Instead of being expelled, they were beaten severely by both the principal and my grandpa. You can't really beat a functioning eye back into someone. This is really awful in several ways. I think everybody sucks here. The kids suck for mixing random chemicals, the teacher and the grandpa suck for beating them, and if any of you repeat it, you also suck, so please don't repeat it. I hope your dad eventually got some of his vision back, and I hope the other people affected also recovered, because that's terrible. Oh my gosh, the fluorescent dye story reminded me of 2 other stories. The first is the fluorescent weekend worker. We were doing some detective work on the balance, as people would leave crap in and around it, and we were trying to figure out who did it. We tried a logbook, but predictably the culprit didn't use the logbook. So on this particular Monday morning, I came into the lab super early. It was somewhere between 7 and 8 a.m. if I recall correctly. I noticed a bunch of junk lying around the balance, and I took some pictures. Deciding I did not want to deal with it right now, I started my experiments. After about 30 minutes, I needed to cure something with UV light, and noticed spots of bright orange fluorescence, basically everywhere. I was a bit afraid because of potentially carcinogenic dyes being used everywhere. So I called the safety officer, and together we decided to check around with the UV light and saw dyes everywhere. When we got to the balance, it was like an explosion happened. On the floor, we could basically see 2 footprints. I could see smudges of the dye on the floor everywhere in the lab, as well as on a lot of the glassware and equipment, and eventually leading out of the lab. A single lab coat on the rack was glowing bright orange, as was the door handle going into the offices. We managed to track the dye all the way to one of the PhD student desks. It turns out this guy was working on the weekend and he wanted to make a solution of dye functionalized silicon nanobeads. This guy used a zero static gun on the weighing paper with the dye on it. The dye managed to fly everywhere. When the guy came into the office, I was told that he was still fluorescent under the UV light. Sounds like he got caught orange-handed. So this is their second story. This was all the way back to when I was doing an internship for my bachelor's. One morning, I came in and the floor leading to the department next to ours was completely pink, bright pink. Upon asking what was going on, I was told that when the cleaning crew came in that morning and started mopping the floor, they used one of those drivable mopping machines, it started to turn pink when they reached the entrance of that department. About a week later, the entire floor was getting replaced. I asked around, and this is the story that I was told at that moment. A PhD student had synthesized a chemical that turns pink when dissolved in water at parts per billion levels. Apparently they spilled some at an unknown time, and it started to spread through the lab until a little bit was walked outside of the department and the cleaning crew found it. Multiple people had to throw out their clothing because it turned pink in the washing machine and it was almost impossible to get out. I was told that this was the second most expensive accident that they've ever had at our university. If that's the second most expensive accident, I would love to hear what the most expensive one is. In some of my research, I was working with hexafluoroisopropanol and some sulfur-containing chemicals, and several of the molecules that I made would turn dark pink even if you only had sub-milligram quantities of it. The whole solution would be dark pink. And I believe I know the structure of these, but I had to be really careful when I was working with it, because absolutely everything would get stained pink if I wasn't careful. Really, fluorescent compounds can be a problem, and it's not something we often think about. I've messed around with home chemistry for many years. When I was in high school, I made the stupid mistake of trying to purify my own sulfuric acid. I purchased sulfuric acid that you can get for refilling car batteries, and I found out that it wasn't as concentrated as I wanted, so I figured I'd just boil the water out of it. I started heating it on our kitchen stove, and it starts throwing out fumes, likely sulfur dioxide and sulfur trioxide. I immediately told my family to head outside, and I opened every door and window I could. I got a nasty acid taste in my mouth, so I decided to wash it out with milk. As soon as I poured the milk into the cup, the surface circled due to the high acidity content in the air around. Definitely not my smartest moment. I now use sulfuric acid drain cleaner from the hardware store. No purifying needed. Be very careful if you're doing any chemistry at home, and if you're not following a procedure, you need to be extra careful. I wouldn't encourage you to do chemistry with toxic chemicals on your stovetop either, because stoves are used to prepare food. While it might be convenient because it kind of seems like a fume hood, do not use it as a fume hood. This is the big story of today's episode. This is a story told to me by my uncle. He was at an industrial school in Italy in the 70s. The professor demonstrated the violent reaction between potassium metal in water, the classic little piece in a vial. The students liked it so much that they tried to steal a big chunk of potassium. The potassium was in a petrol-filled container, that's gasoline for you North Americans out there, and one kid put his whole arm in the container to steal an orange blob of potassium with no storage. Sometimes in storage, potassium turns orange from the formation of potassium superoxides and peroxides. Definitely more dangerous than even normal potassium, but regardless, this is a super sketchy chemical. He has the brilliant idea of putting it in the back pocket of his jeans, and then proceeds to wash his arm in the bathrooms for cleaning the petrol off. With no towel, he just dried his hands on his pants, sparking an extremely violent reaction. Guess what? Water reacts with potassium, and he just wiped his hands off on his pants, setting him on fire. He was far away from the lab, so no emergency showers. Luckily, the janitor, an old man, broke a glass bottle and cut away the jeans, burning himself in the process. The kid survived with horrible burn scars on his whole body. The janitor saved his life, and he also received horrible scars on his arms. After that, the school started searching other students for missing potassium. My uncle was in possession of some, and as he feared getting busted for it, he made it disappear, tossing it from the window. Outside it was raining. Luckily, he only damaged a parked car and made a loud bang. He was not busted after all. Ugh, this story is so stupid. This is so stupid. Potassium is so dangerous. Potassium is much more dangerous than sodium, but sodium is still dangerous. For comparison, you put sodium in water, it will go bang sometimes, but it will usually just melt and then slowly fizzle its way out. If you put potassium in water, it goes bang essentially immediately because it does a coulombic explosion. Very sketchy. I think there's also a bit of blame to go around to the school for allowing demonstrations with large amounts of unattended potassium to happen. And you shouldn't be storing it over gasoline. Hopefully they mean petroleum spirits that are high boiling point, but the idea of having potassium in gasoline is just a recipe for stupid stuff to happen. The janitor is MVP in this story. That school does not deserve that janitor. That janitor is an amazing person. I hope that janitor was recognized for what a heroic deed he did, because he saved that kid's life. And what did he get? Scars on his arms. Today's Yikes awardee goes to this person whose name I'm not going to say. Antimony history. Victorians had a purgative called the Everlasting Pill, made of pure antimony. It was advertised for the whole family. You were supposed to fish it out of the chamber pot after each use, and save it for next time. If you're not sure what a purgative is, it's just supposed to give you the runs. Maybe this would work the first time, but I'm pretty sure if you ate a pill that another family member had literally pooped out, I think that the poop is probably doing more of the purgative effect than anything else. If you think that this is at all a common practice, I'd be interested to know, but this is a pretty weird one. This is definitely a pretty weird one. One time I cleaned a kettle with vinegar, like a 2% solution I think, so I boiled that vinegar to clean the kettle. But I forgot to change the liquid out, and thus I used that water to cook some hot dogs. Spoiler alert, I noticed that the liquid was blue only after I ate those hot dogs. The kettle was made out of stainless steel. I have never boiled hot dogs in a kettle before. If this is a thing any of you have done, I'd be interested to know. It's definitely an interesting strategy. The safety shower fist line reminds me of my dad getting sprayed in the face from the car battery. If you're wondering what this is, in a previous video we had the line, if anyone stops me from getting a safety shower, I'm gonna give them a safety fist, which has to be my new favorite quote. He went to the ER and they wouldn't put him in a chem shower because they were busy. My pa was like, to hell with this, I'll go blind by the time they get me in, and he just took off to one of the showers to rinse his eyes and body. I know there's a line, but if someone has acid in their eyes, maybe just get them to a sink real quick first before telling them to go to the waiting room to melt away. I'm more curious why your dad didn't just shower off in the bathroom and wash out his eyes in the bathroom first and then go to a hospital to assess damage. I think going to a hospital after you get battery acid in your eye without washing it out first is probably a dangerous thing to do. If there's going to be a dad joke at the end, I should submit my favorite chemistry dad poem. Billy was a chemist, but Billy is no more. What Billy thought was H2O was H2SO4. Have a great day.